The second method for solving off the AC gain is to use what we call the half circuit symmetry. So basically the differential amplifier is broken into two circuits and they are symmetric. Each circuit is called half circuit, so we call it half circuit symmetry, which means that if we solved for one portion of the circuit, we can solve for the other portion of the circuit as well. So you only need to solve for one circuit, then you will be able to solve for the second circuit. So in order for us to do that, we have to make some assumptions. Let us make the first assumption. If the two transistors are symmetric and Vn1 is increased by a factor of delta over 2, while Vn2 is decreased by a factor of delta over 2. Ideally, Vn1 should equal to Vn2, that's the DC bias condition, but if we have some differential voltage difference, we're going to say that half of the voltage will go up in V1 while the other half of the voltage will go down in V2. Then we can say that Vn1 will equal to V common mode, this is the DC voltage, plus delta over 2, and Vn2 is basically the V common mode minus delta over 2. Under these two conditions, we can state that the differential input voltage is given as Vn1 minus Vn2 will equal to delta. So over here we defined Vn1 minus Vn2, that equals to delta, which is the differential voltage of the input. Under this condition, Vp, which is the voltage at the source, doesn't change. So, and this is critical to the derivation of the half circuit. So what we are saying is the following. Half of the differential voltage increased in the first circuit, while the other half of the differential voltage is decreased in the second circuit. If that happened, then the voltage at the source, we calling it Vp here, doesn't change. It's gonna remain constant. Then the AC signal at the source of M1 and M2 is 0. That means there is no AC voltage at that particular point, and the source of the AC circuit is grounded. So we can assume that the source of M1 and the source of M2 in the AC circuit is connected to ground, and this is very critical. As a result, the circuit is simplified into two common source amplifiers as shown in the figure here. So as you see in the figure, we have the two resistors R1 and R2 connected to the two transistors M1 and M2, and then over here we have the two input voltages V1 and V2. So now we are interested in the differential gain. So to solve for the differential gain, we got to evaluate Vout1 first and then Vout2, and then we take the difference, and we will be able to come up with the expression for the differential gain. So what we can say is Vout1 will equal to minus Gm times Rd times Vn1, but we already defined the expression for Vn1 to be V common mode plus delta over 2. Then we can say that this will equal to minus Gm times Rd times V common mode plus delta over 2. And the same thing we can do for Vout2. Then we can say that Vout2 will equal to minus Gm times Rd times Vn2, and I will substitute for Vn2 to be V common mode minus delta over 2. So this will equal to minus Gm times Rd times V common mode minus delta over 2. And we already know the differential output voltage to be the difference between the two terms, so which is Vout2 minus Vout1. And when we carry the math, this will equal to minus Gm Rd times Vn2 minus Vn1. And the V common mode terms cancel out. And by dividing by Vn2 minus Vn1, we have Vout2 minus Vout1 over Vn2 minus Vn1 to equal to minus Gm times Rd. We end up with the same answer as we did using the superposition technique. The following statement is very important and it is proven in the literature, so we will skip the proof. Here is the statement. Any two input signals may be divided into two portions, the common mode portion and the differential portion. That can be expressed as Vn1 will equal to V common mode plus delta over 2, and Vn2 can be equal to V common mode minus delta over 2. Such that, to evaluate the V common mode, we can say that Vn1 plus Vn2 over 2, and the differential input voltage here is delta, will be Vn1 minus Vn2. This statement is extremely important. Basically what it says is, if I wanted to find the differential voltage, I simply take the difference. But if I wanted to take the common mode voltage, I add the two signals and I divide by 2. So make sure that we have the common mode voltage is evaluated by taking the average of the two input signals, and the differential voltage is evaluated by taking the difference of the two input voltages. This is extremely important remark. Make sure you keep this thought with you whenever you deal with the differential and the common mode voltages.